Great. Hello. Hello, everyone. Thank you for coming. I was worried that this might be an empty hall. Maybe I should add bots to it because those rooms are like packed. But I'm glad you're here. And I'm Shweta. I'm an SDE, senior SDE with Microsoft in the developer experience team. I'm based out of India. Came a long way to this. There was not a chance I'm going to miss this, visiting this country. And I'm in love. I'm madly in love with data and data pipelines. So my husband's aware of this. He's learned to live with it. So I love working on data not so much of actually working on data, like I'm not a data scientist, but I love getting pipelines made, getting the data together so that data scientists can work on it. And this is something that I've been doing for the last decade. And throughout this, I've realized that there is one big legacy data problem that we need to solve. Okay, and and the objectives of this session is to understand what this or identify this legacy data problem, and I'm sure it may not be called a big legacy data problem, but it exists everywhere, and then figure out some ways to solve it. There are a few ways that I've found that I really found useful, and I'm sure there are 1,000 other ways to do it, and it keeps improving. So let's spend the next 5 minutes identifying. Okay, and after this, if all of you unanimously think that no, there's no such problem, we can all go. I need to get some nails done, but most likely we are going to stay and continue towards this session, right? So what is big data? I mean, all of us know all of us talk about big data. Okay, and Wiki says big data is a term for data sets that are so large or complex that traditional data processing applications are inadequate to deal with it. I would add more to it, right? I mean, big data is just not the big size. It's varied formats. It's varied structures. If we are talking about we're talking about processing structured, unstructured data, JSON images, text files, all at once. We want to know everything. We want data. We want to make sense out of all of this data, and that is big data. So this is a slide. I don't know. All of you must have seen. It's pretty common that this is our traditional data warehouse, right? We have data sources. There are OLTPs, ERPs, CRMs. Then we have ETL tools, data warehouses, and then we have dashboards. So there's some exec who gets a report every 15 days or every week or every month on how the sales is doing, how their marketing campaign is going. So each director, each department has its own set of reports that they make and they give. And what has changed over time is volumes. It's gone crazy, right? The amount of data that's being generated even within these silos is crazy. And second, real-time data. I mean, how many of you are aware of Bollywood? Okay, thanks. So there was a movie, it's 1970s when I went, when I love watching that movie, and in that movie there's this manager and this employee, and the manager says to the employee, what happened to that client, that issue with the client? And he says, I sent him a letter, and we may get a response after 15 days and then we work on it. And he says, wow, that's great, you're so super efficient, and he gives him a promotion. So I miss those days, but that's now how it is, right? Today we don't want a report that works on 1 month old data, and we still have that. I mean, most of the enterprises, by the time like my husband, he works in a chocolate making company, nothing fancy, I never get free chocolates, but he spends 1 month on getting reports from various, he handles the Asia Pacific and EMEA. He spends a month getting reports from all of these departments. All of them have SAP, Business Objects, Oracle, and name it. They have the latest systems, but they take a month to come up with reports that finally goes into budgeting and forecasting. So we all know that there is this real-time data problem. We still haven't solved it. Then of course now we have new sources. I mean, I've launched a new marketing campaign. I'm a bank, I've just launched a new scheme. I want to know how it's doing. I want to immediately know, is it making an impact on my sales? Is it making, what are people talking about it? So there are new data sources and types that have come. Then of course we have the cloud-bound data and the on-prem data. So if that was not enough, we have the complexity of location. So I've just taken the diagram and tilted over, so it's easier to read. So we have the new data that's coming in. It all goes into this various. So we have new data types. We have HDFS, blob storage, and whatnot. And it's all nice. It's all there. But is it really true? Is it that simple? I mean, do we have everything that we have one ETL tool to transform all the LOBs and stuff? Do we have one to transform all the additional data? That's not true, right? This is all theoretical. In real life, we have different departments, different geographies, different systems, which result in different ETL tools. And then, of course, results in disparate systems. Similarly, we have the same problem in all kinds of data sources. So eventually, we land up in the big legacy data problem, right? And your data ends up being repetitive with different interpretations, inconsistent, incomplete, and in multiple formats, right? So we all agree that we have this problem. Agreed? Yeah, and you're not going out. So So I was reading through for this session, and I came across this interesting term called data drift. And this actually has been defined in the source. I've given the source there. It's been defined by the StreamSets guys, the folks at StreamSets. It says that the changes in data, schema, software over time, and it's so important to understand what is the cause of the big legacy data problem. It's very clear. So we have structural changes. We have addition of fields. We have deletion of fields. For example, fax numbers have disappeared from a lot of databases. We have addition of email IDs, hopefully. Then we have meaning of data changes. So let's say you have an account number. Earlier, the account number had 10 digits. Maybe the first 4 digits was your country code. The next 3 digits was your branch code and stuff. But you added your accounts increase, you make it 16 digits. So your data has changed over time. But when you're looking at building these really large scale predictive analytics system, you need that data. You need that data across to understand trends. And then infrastructure, your software versions have changed. The earlier version used to work with tab separated files, and now they have these awesome XML files that they're working with. So you have different versions of the software. Then the other issue is the legacy and stringent ETL systems. So most of the ETL systems that we work on have or expect certain kind of data or certain format of data. Each system could have its own input set that it works with. So you would have something that works with all RDMSs, and then you would have some which works with streaming data. But having one which works with both is most likely not there. And then they output into different things. So some will output into directly into a cube, which goes into a BI system, or some just puts it back into an RDBMS system. And then you have structure. Some works with XML, with binary, with JSON, with text, with images, and so on. So we have what do you call, and worst part is each of them, so all our data sets, each tag means something, each value means something, and then a lot of them, or a lot of ETL tools are written custom built for that specific data sets. So these are the two issues according to me that cause major problems in legacy data, the problems that we spoke about. Just give me a minute, my laptop is going to sleep. So I have some thoughts on how we can address that problem. I think two key things. One is embracing the cloud. I mean, unless you have thousands and thousands of servers just lying free, doing nothing, ready to do some work, it makes sense to embrace the cloud, right? And it brings in scale, because we need that scale. Investing so much on an on-prem system and buying that kind of infrastructure doesn't make sense. security. Now it's kind of counterintuitive, because whenever you go and speak to an enterprise and you say it's secure, they're like, excuse me, it's a public cloud. But then we get into a conversation where we tell them, you're not in the business of managing data or managing data centers. You are in a different business. We are in that business. We give you far more security than you would to prevent your own data centers. Then cost optimizations. Now clearly cost optimization is debatable. If you just take the whole server and put it up on the cloud, no, there's no cost optimization. You might end up paying even more. But if you really smartly architect a solution that solves this problem, then it does bring in cost optimizations. There are some slides, but I'm going to show a demo, so please bear with me. And the other thing is that there's no one right path, according to me. There is no right solution that will fit everything. There's no magic formula. And every scenario, we need to address it differently, and we need to actually look into what is needed. But I also think that we do have right tools. If we have the right tools, we can set or fit, we can actually solve at least 50 to 60% of the big legacy data problem. The remaining is very specific to that scenario, which we have to build around. So one is Azure Data Factory, which I think is, to be honest, for me, not just because I'm working with Microsoft, but I really think that this product is like one of the most underutilized, underknown, underachieved product. It's beautiful when it comes to working with legacy data. It has ingestion. It works with data sources. You can prepare, mash your data, get everything together, and then we'll see that in a demo how we can actually implement it. You can transform it. You can analyze it. You can push it out to, and you can integrate it very well with a lot of systems. So I really, and all of this with scale, with monitoring. It's a cloud-based service. Okay, so and it's so generic that it could actually technically solve a lot of problems or a lot of scenarios by itself. And talking about data sources, these are the data sources which it currently supports. It's continuously evolving. It supports on-prem and cloud. You can look at almost all RDBMS softwares like SQL Server, Oracle, DB2, MySQL, NoSQL, Teradata, Postgre, Cassandra, Amazon Redshift, then file systems, HDFS, then of course the Azure sources, and Salesforce. It also has GHistorian, Webtable. Now this is not exhaustive, and I'll show you how. I mean, you need not be limited to these data sources. These data sources are there by default, but it doesn't mean that if you have a data source that is not a part of this list, you can't use it. And we have this copy activity, which I mean, so it starts with, it provides you large scale copy, and and later down the line we'll understand the importance of it, because when you're getting your data is on your on-prem to the cloud, or you have to do a lot of processing and bring it back to the on-prem, this adds a lot of value, because you're moving GBs of data and you need to move it in a secured way. At the same time, you need to move it fast. So you need that monitoring capability. You need that capability which ADF provides it. I know it took me an hour. An hour is also an exaggeration, but it took me less than an hour to set up an entire copy activity that could copy like GBs of data from to and fro into cloud. It also takes care of serialization, compression, and mapping columns. So you can take SQL, you can take data from Oracle's SQL Server and put it into a data warehouse, or you can take MongoDB and put it into blob storage. So you can do transformations, you can do mappings on that. So these are some of the transformation activities. Again, this is not exhaustive. These are there by default, but you can add and complement to it. Like you can write Hive jobs, Pig jobs, MapReduce jobs. You can invoke our machine learning scripts, Spark scripts, and of course write your own custom activity. Unfortunately, it is still .NET, but there are ways to put in your open source code as well. So, so how is it different? You can do a Hadoop job you can set up a 12 node Hadoop cluster and do it, but if you ever try setting up a 12 node Hadoop cluster, you will realize that it's not simple. And running a 12 node Hadoop cluster in production environment, you will need an army of really super smart people who will maintain that. Okay, so ADF allows you to create these clusters on demand. So let's say if you're doing like most of us, when we're doing this big legacy data thing, we don't need them 24/7, right? We probably would want all the data to be consolidated once in a day or once in an hour. We can actually set up an on-demand cluster that it spins up a 12 node or 14 node or whatever node cluster. It runs all the activities and it shuts it down. So you're just paying for that 1 hour or 2 hours that you really needed. So it just beautifully fits well with our problem that we are trying to solve. And you can run any of these activities on the Hadoop cluster. Other interesting thing is that we have the hybrid support. We've partnered with Hortonworks, where you can do part of the activity in your on-premise Hortonworks Hadoop and then continue with the rest of it in cloud. Okay, so the advantage here is, so if due to data sovereignty issues or whatever your customers' comfort level issues, if you're not open to having your sensitive data or PII information or sensitive data to move out, just do the processing to make sure that the sensitive data is matched or masked, and then you just move the relevant data up to the cloud to continue processing and doing your analytics. So this is available. You can try it out yourself. How many of you heard of stream sets? No? Okay, so to be honest, even I hadn't heard about them. I was creating an HD Insight cluster on Azure when it suddenly said add new applications. There was a new blade, and then I see stream sets. So I was very surprised what's the stream set. So I went on their website. I really like the way they have the information. They really present well. It's an open source thing, but they have their enterprise versions as well. So what stream sets does is quite similar to what ADF is. It's just that stream sets it works on Hadoop. It works on Hadoop clusters, and it allows you to build pipelines as well. So it basically allows you to get data from various sources and run your jobs, data processing jobs, and push the output. That also has a monitoring dashboard. I'm still to try. I was struggling to set up a Kafka consumer for some reason, but I wanted to show a demo here, but I couldn't. But I think this is definitely worth exploring. They're just new, so this could be one of the solutions that we have that we can use. These are some of the data sources they work with. So it's pretty extensive, and I'm sure they're also continuously going to work on processing this. I mean, adding stuff to this, and these are some of the processing they do. So they are now available on HD Insight as an add-on. So you just have to go, and when you create a cluster, you can just say I want to add stream sets to it. It will install. So I think we've partnered with them. So these are two options that I think are very close to which could help us solve a problem. So now what I would like to do is, let's take a case study. It's a real world case study, something that I've worked on, and I thought that it'll be interesting to see to see how we've actually solved that problem with ADF. So it's a medical equipment manufacturer. Anyone who's done engineering here? Okay, so those icons are actually of hydraulic drill press and some crazy heavy machinery. These I realized it after I put them in the slides. So don't worry, the medical guy is not using these in healthcare facilities. These are just icons. So they actually manufacture medical instruments, and so each equipment has its own division. So so for example, there's X-rays, the X-ray machines, and obviously each of those machines are very, very complex, and they have their own divisions, own set of people, own software teams working with them. And then they output monitoring data. So traditionally what was happening was that this data is stored on a local server, and whenever the machine goes down, someone comes down and then extracts the data and tries to find out what went wrong with the machine, and probably takes some inputs back into the system to figure out what, and I'm sure those inputs are ignored, but that's what the process is. So obviously each team had their own set of technologies, they had their own set of data formats, and someone liked CSV, someone liked XML, someone loved tab separated files, I don't know why, but everyone had their own formats. And obviously they had their own tag names. Now the information was very was specific to a device, but when I started working with them, they had 350 such tag formats. So imagine each equipment is sending its own file, and this is not something hard to believe. I mean, this is something that will happen everywhere, right? So what happened was that they decided that, you know, we'll bring a value add service. We will take this data, we'll have them push all this data to our on-premise systems, and we will process this data real time, and we'll instantly generate a service ticket the moment we detect there's something wrong with the machines. Now obviously these are medical equipments, they're very, very critical machines. I mean, if I'm going for a blood test, I don't want that thing to give me a dangerous disease when I don't have it, right? So I want to make sure that my medical equipment is working fine. So they created this crazy system, and the way it works is each facilities, they have their own gateway servers. They send data from, so all the medical devices send the data in their own formats to the server. Then the gateway server gets all the data files together and pushes it every 10 minutes. And then they have this FTP, they upload it to this secured FTP server on premise. Then they have this scheduler application. Trust me, it took me a month to understand, so please, I tried to simplify it as much as I could. But the Java scheduler takes in these files, then it identifies the metadata, what's the healthcare, what's the device ID and stuff, and then adds it to the metadata and pushes it to a queue. Now there's this Java processor, which is they're very proud of, takes in this files, and it determines runtime, what kind of parser it needs. So they have 350 Java parsers, 350 different Java parsers, which take up, so the respective parser takes it up, processes it, pushes it into an Oracle database, and they have 4 to 5 tables for each device to store data, and then they have 1750 Oracle triggers that work on this data. And then they have a scheduler which checks so the triggers run, they check for data that's come in, if it detects an anomaly. So the kind of data that they have, so let's say if a particular device is sending a particular value which is greater than 5 for next 20 minutes, then there's something wrong with the device. So this device is sending some alerts. So this processor picks up that alert and then pushes it to their service request, and that service request is assigned to a person who go and attend. So basically early warning system. So it worked pretty well for them, and maybe once they started scaling, the system currently works for around 10,000 devices. That's like 1.4 million files a day, and the biggest challenge is they can't scale. They simply won't scale in this manner, right? I mean, they've got what, 100, they wanted to scale it to 100,000 devices, that's like 14 million files a day with 350 parsers. It just doesn't work. And the other challenge was adding any kind of instrument types, making edits would easily take 3 to 6 months. Then obviously it was very expensive. Okay, running that kind of compute for a simple value added service was not making business sense for them, but it was a very critical piece of their service. They wanted to make sure that they do it. So what we did, so we used ADF, and we targeted 3 key pain points that they had. One was of course the scheduler, right, which takes in, that's a point of failure. If that FTP server goes down, then I am then nothing works. Then the file passes, because adding any kinds of instrument types or modifying, making edits to it is going to take ages. And then of course those Oracle triggers, which are critical, but then they were not able to scale it to the kind of data that was coming in. So, so the first thing that we solved was using a file parser. Now, this is actually related to what we want to do with the data. Okay, so what we wanted to do with the data to run those real time checks, right. I want to know if a particular device is sending me a value of some parameter which is greater than 5 for 20 minutes, and then it is sending me 6 for next 30 minutes, then I really need to create a service request, or there is something wrong with the device, a device with errors. So, I thought stream analytics was one of the would fit the solution pretty well, because stream analytics, you can write these conditions, and stream analytics can work on non-SQL data, which is like, I do not need an expensive SQL sitting over there, because SQL is great with transactional data, but when I am working on per device, I do not really need that kind of processing. The next problem was 350 different file types, and mostly XML and CSVs. First thing, stream analytics does not accept, it only accepts JSON. Second, I have to work with, I mean, it accepts CSVs, I think, but it definitely does not accept XML. So, I wrote this framework. It's basically transforming XML into JSON and CSV into JSON. So, if you look at the screenshot here, it's just taking the XML structure as is and making a JSON document of it. It preserves the hierarchy, it preserves the tag names, it preserves everything. So, that 350 files could all be transformed into JSON, and then I leave it at the stream analytics to figure out what needs to be done. So, this worked really well, and what we did, so we added first we could not get rid of the gateway FTP thing, because they did not want to go to every healthcare facility and modify the systems to push data into cloud. So, we just had a web job that just takes all the data from the FTP and pushes it into a blob storage, and then we had sorry for the wrong ordering of the text, but so then we wrote, so what we did was, so I wrote that framework that takes the data and transforms, but obviously we need scale to it, right. That is why I added ADF. So, I created a .NET activity that scales or transforms the data, and then that pushes it into a storage. Now, stream analytics, if you notice, is outside ADF. It is not one of the supported activities, but it works pretty fine. It takes the input from the blob storage, runs the queries, pushes it back to the blob storage for alerts. So, it creates records of all the devices that need to be taken care of, and then I have a data copy activity that takes it and then pushes it back to their Oracle database on premise, and the service request works as is. So, this kind of worked, and it helped them scale pretty well. And let me just, what I would really like was that remove this whole FTP business, have a data copy activity in the ADF, which just copies all the files automatically at scheduled intervals, and then push this data in, and then maybe just use a service bus that directly invokes their on-premise systems. Now, why ADF fit the solution, the bill very well was that tomorrow if they move their on-premise systems to cloud, or tomorrow if they add more data sources, it would just be as simple as adding pipelines, because their underlying infrastructure, the pipeline was built. So, let me just show you a demo of, so I obviously could not really build, I can't really share what we did, because it is a healthcare company and they are worried about IP issues, but I built a demo. I had to recreate the whole thing. So, we just zoom in. So, I have this data generator program that is generating three kinds of files, 2 XMLs and 1 CSV. So, actually I do not need to show you the code here, it is nothing great. It's basically, let me just get this started. So we have the files generated and then I'll explain the code. So what this is doing is generating 3 kinds of files. I'm calling it type A, type B, and type A, type B, and type C. So type A is, if you notice, it's sorry, oof. Type A, if you notice, is an XML. It's got some data, like it's got some readings T1, X2, Y1, and it's got a value and a timestamp. It's just an XML with some data in it. Then type B is another device in our scenario with its own XML format, its own tags, its own names. And type C is a CSV. It's again got its own data, its own names. Okay. So what I'm doing is this file generator is generating thousands of these files and putting it in this folder, which is disappeared. Just give me a minute. So it's generating these files. You see, it started generating 175, 178 generated, and now that it is done, I have actually a ADF data factory that I've already set that takes these files and copies it into a blob storage. So I have this data management gateway set up, which is ensuring that there is the compression, serialization, and authentication. So you need to register it with ADF, and this data management gateway is going to pick up all this data and push it to blob storage. Now it's going to push it to this this XML CSV to JSON input storage account with files to process as a container, and it's going to partition it by a date. Just take some time. Similarly, once the data is in the blob storage, I have this, let me open it up. I have this transformation. So it's going to take all of these XMLs and CSV files and transform it into a JSON object, which is going to be stored in this output. And then I have these stream analytic queries, which are going to take that output, run the queries, and then push it to a common dashboard, which is a Power BI dashboard. So let's pray that for the demo gods that it works. So let me see. Okay, it's going to take some time. Okay, while the data is being copied, let me actually show you how it works. So we have this on-premise file share. Let me actually just ignore the errors. I was working early morning and without coffee, so I introduced some errors. But go to author and deploy. So I have this link service, which is basically my on-premise file server link service. So this is where I've said that this is my account, my login account and password. Use this and log into my on-premise service and go to this particular folder. This is the folder. Let me just go to this folder and get me all the files and upload them. And if you look at the pipeline, the data copy pipeline, so its type is copy, type is file system source. So I want to copy the file system source into a blob, and my input is the on-premise file service and my output is a blob data set. So I am basically taking, and this is a simple JSON file which is created, and it also has copy every 15 minutes. So that's the minimum you can at this point in time in ADF use the copy activity. So every 15 minutes is supposed to look and copy data, and once that is, so my output is the input is your blob set. It's very confusing. Output is an input, but because that comes and is an input for my transformation. So that takes the files that I have uploaded from my on-premise onto the cloud, and then I run this custom activity called process XML CSV to JSON. Now let me show you the .NET activity that I created. Let me zoom that, I think that's better. So this is a .NET activity. Funny thing is, I was a .NET programmer before I joined Microsoft, and since I've joined Microsoft, it's only Python and Node.js that I'm working on. But I got a chance to work on .NET again. So this is like, so you just create a class which is inheriting the i.NET activity class, and we implement the execute method. Now everything that I'm saying is available online in the documentation, and what I'm doing is basically I've created data sets and from the storage accounts, and I'm able to get the connection string and everything. And then what I'm doing is I'm just calling this list all the blobs. So once the data has been uploaded, give me all the blobs one by one. And one thing that I want to show you is that once I get all the blobs, now this is very specific to this customer, right? Because like I said, there are some things that you can't help it, it will be very specific to the scenario. So in this scenario, I created file names with type A, type B, type C. So that determines what's my device type or what's the type of the file it is. So I'm using that to determine the type, and then I'm calling the and then I'm defining whether it's an XML or CSV, and I'm calling these functions that I've written, XML to JSON. Now all of this is available on GitHub. It's an open source code. So when you're working with data and you need to do some kind of transformation, just feel free to use this code. And if you find that there are formats it doesn't work, I've tried it with an XML with 16 steps, 16 hierarchies, it worked fine. But if you still have XML that it doesn't work with, just please reach out to me. Now, so this is an important part that I'm actually adding the, are you able to see it clearly? Okay. I'm adding the metadata to it, where I'm saying that the metadata of this blob storage is file type and type A, type B or type C. This is an additional field that I'm adding to all the JSON. Now if you see the, so this is a type A file, and if I just show you the transform JSON, it's adding a metadata. So it's a wrong, I'm just adding type A, it's a typo, but then it's just transforms the rest of the data. So this additional field that I've added, which I'm going to use in my stream analytics, because my query needs to determine is this a record am I supposed to process or am I supposed to draw. So I go to my, so this is a query which is process type A record, and for type A I just want all the count of all devices where the reading is greater than 2 and some value is greater than 1, is less than 1. So give me all the records where a specific value is greater than 2 and less than 1. This is similar to what the healthcare company wanted, and I just run this query on the entire blobs. So it doesn't matter what file type it is. If I had 350 file types, I will just have 350 queries to work with. It's still not great, but at least what it really solves the problem is I don't need file parsers. I'm not parsing. I've removed the whole parsing, scheduling, everything. In one go, it just transforms everything into JSON, and then these queries take the data, they'll drop. So I've added this, let me zoom it. I've added this field called metadata.fileType is equal to type A. So only those records that belong to type A will be processed by this query, and rest everything will be ignored. Similarly, I've added type B. So if I look at the query, I'm still praying to the demo gods in the background, but so here I've added type B. So if you look at this query, it will first get me all type met records where file type is type B, and then from that I'm just doing a count. So it's a very simple query I wrote. Those queries were far more complex. I was really pulling my hair out, but it works. So we just reduced the whole transformation and we gave everything to ADF to manage it. The best part was it can scale. Today I have 100 files. Tomorrow I've run this demo with 100,000 files and it works fine. Because ADF handles that scale, I don't have to worry about it. and the .NET activity that I have uploaded is actually running on an Azure batch, which is a part of the data factory. So, let us see if my file started coming. Yep. Okay, I have this. So, it is created a folder to the, it's okay. Other thing is it like Hadoop, like Hive or Hadoop, where you can partition data. You can define your partitions here, and I have defined my partitions as year, month, day, so that I can easily partition my files by days, and that is typically how everyone uses. So, I will just so these are all my files. So, these are the files that I have uploaded. Now, if you see, they are XML files. It's just taken everything that it has found and dumped it. It does not matter what type is it. And then if I go to the process files, these should be JSON files. So, all the data that all the files that I have uploaded would have been transformed into JSON. So, you see, these are all JSON files. So, you see that it works, right? It works at a very large scale. So, if it does not matter now if I upload 100,000 files, it should work. And what this stream analytics is doing is it's just getting this. So, it's just getting a count, so device with errors, and this output is actually a Power BI output, because I did not want to really set up an Oracle database and create triggers, but I just push the data out into Power BI. Now, let me do a refresh to see if it refreshes. Yep, it refreshed, right? It just instantly gave. So, what did I do? I just created these files, assume they have come from medical records, just push them on ADF. It transformed all of those tag XML, CSVs into JSON, and then I just had 3 queries, each specific to a type of device I am working with, and each of these queries could just take input of all the JSONs, drop all the records that they do not care about, process the records that they care about, and then instantly push it into a Power BI. So, this could have been a real dashboard, or this could go back to that healthcare company's service dashboard and say, hey, these device IDs are giving errors. So, I could actually, I mean, we could actually solve that problem. Now, this is just a small part of what they want to do, right? I mean, I want all this data, and maybe I want to combine it with the invoices, or I want to combine it with the service requests. I want to combine it with the equipment manufacturing date. I want to combine it with the number of patients, the healthcare facility, or number of times that device is used, and then probably build models that can predict, right? So, if I want to do that, this is just one data. I will probably have to integrate it with my sales. I will have to integrate it with my services. So, I can actually keep adding sources and pipelines and outputs and get the whole output in place. So, back to our presentation. So, this is my last slide. I think we are early, 4:15 to 5:15, yeah, 15 minutes. So, we can probably have a discussion, questions after this. So, few things that I think we need to for systems to solve the problem is, one, the system should not have, absolutely should not have dependency on the schema of the data, because that is the whole problem we have, right? Because we have systems that depend so much on the schema, and when the schema changes, we are in trouble. So, a system that will actually solve the legacy data problem should have minimal or no dependence on the schema of the data. Second, ability to work with multiple data sources and technology. It should not matter what is the data source, whether it is Twitter stream if Twitter survives, or if there is Facebook, or if there is clickstream from a website, or if there is SQL data that is coming in from a transactional point of sale system. So, it could be any source, and multiple formats, right, because that is one key thing. So, if we have data in different formats in different systems, it should be able to do that. Then It should support multiple processing options. So like in this system we had Stream Analytics, which worked on querying and running real-time analytics. At the same time we had a .NET activity that transformed or processed. At the same time you can add MapReduce or Pig or Spark or R. So you can run multiple or multiple technologies or multiple data processing options. Similarly with stream sets. In stream sets too you could add multiple technology options. Then it should support multi-locations, because it should support running on premise or running on cloud, running on both, combining both, and also ability to move it up and down, because you shouldn't want to be stuck on one single cloud or something, right. You should always have an option to move out if you don't like it. Then monitoring, because we want to know when the data is bad, we want to know when the data is missing, we want to go and fix it or go back to that department and fix it. And of course scale, because it has to scale. It's only going to increase, it's never going to decrease. So that system should scale, and once it succeeds with one such pipeline, it just adds. You will always have people adding on to it and saying, okay, let me have this data, or let me have that data, and let me add this report. And the system should be able to scale to cater to that kind of data sizes. And of course data warehousing, because all that data that you're collecting should be stored somewhere, because we'll always use it, right. So these machine learning models, the way their ability to predict largely depends on the quality and the size of data sets that are sample data sets that is available. So I think that's about it. So that's all I had to talk about, and I'll be happy to answer any questions specific to what I showed, or even not specific to that. So please. One more thing, I will along with the slides I will add the GitHub link. So all the code that I have just showed will be made available on GitHub. So all the generation code, so you can try it out all by yourself, creation of the ADF to see how it works out, and also the transformation. So the transformation is a simple .NET code which you can just feel free to use. It's an MIT open source license, and use it in on premise or wherever you want to. Oh, thank you. Go home.